I was doing a little preliminary work for my Glass Revolution project for this summer. So I developed a Suntracking functionality based on this Picaxe chip. I kind of overreached or outdone myself because I was thinking about servo functionality, but it's quite useful. It's basically a solar tracker functionality that's very easy to use. These chips are extremely versatile in my opinion. They do serial output and input, they do I2C, analog to digital conversion, touch sensitivity, pulse width modulation. All these functions are included in these chips. You do have, if you take a small one like this, a restriction with your input and output. So I was basically trying to figure out whether you could do time-based servo control with this one, and I've yet to figure out how that would work. I don't think it has enough pins for that, enough inputs and outputs. But for what I'm trying to, or what I built today, it's actually working. This chip is more than able to do the job. Here you can see the schematic. What I want to do is simply detect the direction of the sun. So I have my one-axis solar panel. Here on the top I have a photodetector. Looks like this. It has two LDRs, resistors. These are classical components that have been around for a long time. That basically were part of the first electronics kits that I ever got my hands on. These are two resistors. They are equal photoresistors, and if one gets more light than the other, then the potential in the middle shifts. So if this one has less resistance than that one, then the potential shifts to this side, to the side of the ground, so to the zero. And if this one has less resistance than that one, then the potential shifts towards the supply voltage. The chip, the 8M2 chip, has analog to digital conversion, which means that it simply puts out a number which tells you exactly where in the range between the supply voltage and the ground voltage you are with your potential that you're offering it. So that makes a very simple circuit. You have these two resistors. You can put another resistor in this connection, but that won't influence the potential at this end, and the chip will see a value between let's say 0 and 1023, and if these two are balanced because you are exactly towards the sun, then the value will be 512. So you could write a little program saying, well, if this is above 512, then we put out a binary signal for the engine controller, for the motor controller, to turn it to the right, and if it's below 512, we turn it to the left. That all depends on how you mount all these things. So the absolute relationship between the value and the direction is not, don't kill me for being wrong about that, but it's about the idea. But you only need this half of the chip to do that. I ended up making this half of the chip actually by accident, because I thought, well, you need to tune this to a set value, and that's not necessary. But this ends up to be useful. I used here a linear rotating resistor. Looks a little bit like this, and what it allows me to do is to set the value at which the motor will switch direction. And that means that if you have this panel, you have the detector mounted, then there might be an imbalance still a little bit between these resistors, and you can so the value that ends up here is not 512 but 480 or something like that. That means that you with this resistor you can simply say, okay, we'll turn it a little bit until the motor stops turning if the panel is oriented towards the sun correctly, and from that point on this will work exactly as it used to with it, as I described before. So you can basically set it to a certain, you can adapt it to work properly. You still have a number of pins, 2 pins left, which is nice. So you can have a C3 which you can detect the endpoints. And of course, you could say, well, if you reach the end point here on the right side, then let's say where it ends up at the end of the afternoon, then you do a whole different program and you run it all the way back. So you basically control the motor to run the whole panel back to the starting point, which is another switch, which is C5, and if it detects C5, then it waits until morning. I'm not sure yet how that works, but by that time it will be pretty dark. Actually, this thing has an internal clock, so as long as it gets power, it can count seconds, and you can move this back and make it count for 8 hours or something like that. That won't be very precise, but you can simply let it sleep for 8 hours, which makes it consume very little power. And then after 8 hours it will switch on and try to do this whole routine. On the breadboard, it looks like this. It's very little parts, so you have the Picaxe chip. These are two LEDs that show me what the motor control was. So one switch is on, and if you, let's say, move either the set point or the light sensor, then the other switch is on. And there's some resistors. You need a power supply. You could use a solar panel for that, actually. You could also use a solar panel to drive the motor. And this is the code where you basically read the two analog to digital conversion inputs from the let's say the setting resistor and the photo resistor pair. You compare them, and if one is bigger than the other, then you start moving to the right, either to the left. And this is simply you take the input, say 3, you make a little read switch or a very light switch that you put into this input, and when it gets triggered, you switch off everything. You switch off the engine. So when it runs into this end point and it switches on C3, then both the values of the motor signal go low. This is a very basic implementation. Of course, what I talked about is a little bit more complicated. If you talk about parts for this, these chips are about $2 or $3. This is about $4. These things are, these LDRs, they are like a few cents. So actually this is not very, well, I guess motor controllers are about 10 euros. That's a very expensive one. You need other stuff, of course, to make a whole device, but, well, I guess this could be a very easy way to get your own solar tracker. And that's about it. I could offer programming these. I'll try to build a fully programmed one and demo it, but that requires a lot of time. I'm actually looking for using the clock. So because of course this setup has a sensitivity to clouds and can show hysteresis, which is that it doesn't really know which way it has to move, and it moves back and forth. All that type of phenomena can occur. But I think to do a true servo type tracking with a number of other functions, you have to start with the Picaxe 1.4 M2 and M2 at least. I have one of those as well. So I guess that will be my next presentation, and I'll try to get a little video of this in action. Thanks for listening.